Number 7. Uh-oh, I lost the thing. Here it is. Number 7. Block 1 of mass M1 slides along a frictionless floor and into a one-dimensional elastic collision with a stationary block 2 of mass 3m. So here is my drawing. Number 7, worksheet. What are we on, 10.4? So here's my before drawing. Block 1 has a mass of m1. I'm just going to call it m. All right. Here's block 2. It's got a mass of 3 times m, right? Is that cool? Let's see. Prior to the collision, the center of mass of the 2-block system has a speed of 3 meters a second. So the velocity of my center of mass is 3 meters per second. That seems like it. Let's see what else. Oh, we also know that this guy... I'm going to move this. I also know that the velocity of block 2 initially is 0, and I know that the velocity of block 1 initially is not. Okay. Let's see. A, afterward, what is the speed of the center of mass? So 3 meters a second, right? Everybody cool with part A on that? Right? There's no external forces. The velocity of your center of mass shouldn't change, so it's still 3 meters a second. Cool? All right. Part B, I think, is the tougher part. Afterward, what's the speed of block 2? Well, how do I want to do that? So solving this relies on the realization we just made at the end of that last problem. That, how do I want to say this? The velocity of the center of mass is the mass of A times the velocity of A plus the mass of B times the velocity of B over the mass of A times plus the mass of B, right? Cool? And again, this is my total momentum. And what should be true about the total momentum? Should be constant, right? Oh, well, let's plug in some numbers. Let's see. The velocity of the center of mass is 3. That equals my total momentum, right? This chunk here is my total momentum over my total mass, which is, 4m. Right? Follow? Oh, well, that means that my total momentum must be 12m. Make sense? All right. Now, what else do we know? I kind of just dove into that headlong without sort of doing any calculations. There's something else we know that I have not made use of yet. And I said it in a deep voice when I read the problem. Elastic, right? It's an elastic collision, right? Good. So what I know is that I totally just lost my footing here. What am I doing? I know that the velocity of one initial physics, that was good, plus the velocity of one final should equal 0 plus the velocity of 2 final. I know what I'm doing. Okay, cool. So that's another thing I know. All right, so thoughts about where to go from here? We can find something relatively easily. Patrick?
Well, you can find the velocity of the thing that's moving, because momentum is mass velocity, so you can cross out a lot of times.
Yeah. Look, before the collision, isn't all of the momentum in block 1? Oh, and we know the total momentum. Oh, and we know the mass. Oh, so what does this velocity have to be? It's got to be 12, right? Because my total momentum is 12m. This doesn't have any momentum, so this must have a momentum of 12m. So that velocity must be 12. Follow? All right, so let's replace this guy with 12. All righty. So, ideas about where to go from here? one of these now. Let's see. The total momentum after the collision should be the mass of A times the velocity of A and B, should be the mass of 1 times the velocity of 1 final plus the mass of 2 times the velocity of 2 final, right? So let's see, we know our total momentum should be 12m. Mass 1 is m. V1 final we don't know. Mass of 2 is 3m. And V2 final is, this, right? So I'm going to replace V2 final with this. Oh no, I'm out of room. Oh, that'll give me just enough room. Is that better, sir? Sorry, you were craning your neck. We gotta move you up. You're always ducking and weaving. All right, everybody good up to there? All right, so the m's cancel out, right? And now we can solve this thing. So what are we gonna get? We got 12 equals V1F plus 36 plus 3 times V1F. Subtract the 36, you're gonna get, negative 24? Why are we confused?
One bounces back.
Yeah, that makes sense. Okay. Yeah, I think we're good. So yeah, so subtract, okay, so hold on, pause. I heard I'm confused. Where did I lose you, Paula?
Nothing, just when I was looking at this, never mind. I wanted to go on. I didn't know.
You're good?
Yeah.
Anybody I'm good? Okay, so subtract 36, you got negative 24 equals V1 plus 3V1 is 4V1F. Oh, V1 final must be negative 6 meters a second, so it must have bounced back. Which means that V2F is positive 6. Cool? Questiones. Did I do everything there? Yes. You good, Matt?
Yeah, it started at rest.
You what?
It started at rest.
Gotcha, yeah. All right, problems, you guys? All righty then, so that was number 7.